with that, we have a speaker who has repeatedly been at the New York conference, and this is the first time we have gotten him to the DC/government conference. I'm really excited because he does a lot of political science work, and he does a lot of forecasting on the elections. So we're going to hear how he did, whether he nailed it, did terrible, or got somewhere in between for this year's election. There's so many things I could say about him, from the greatest living statistician, and that's not going to make him nervous, to a fun teacher, to everything we could talk about. Everyone, please welcome Andrew Gelman.
It's a pleasure to speak in Washington, D.C., even though I can't be there myself. I grew up in the suburbs of D.C., and my parents both worked for the government in non-supervisory capabilities, but nonetheless, they did. And I just want to thank all of you for all of your public service. I would like to thank the previous speaker also for his service. I have never been in the military, but when I was a student, I did work at the Naval Research Lab in Washington, D.C., right next to the sewage treatment plant for a few years. And I learned a lot of science there too. So today I wanted to talk briefly about election forecasting, and it was fun writing the title of the talk because I sent the talk title in October before the election had occurred. So I titled it How We Succeeded Brilliantly, Failed Miserably, or Landed Somewhere in Between, which seemed like it covered everything, except people don't really like the landed somewhere in between part. Like, everyone wants things to either succeed brilliantly or fail miserably. And one of the messages we have in statistics is that things aren't binary in that way. While the election's binary, there's a winner and a loser. Public opinion is not binary. Science is not binary, and the success of a forecast is not binary. One of the problems with people's perceptions of election forecasts is that they swing back and forth between thinking that a forecast succeeded brilliantly and that it failed miserably. So people are overreacting in both directions. Now, before the forecast occurred, I was going around telling people, well, I was going around telling people that I hope that our forecast is perfect because it'll make us look good. But then after that happens, I want to explain to people how we just got lucky. And this is what I wrote at the time. I posted something after sending Jared the abstract that I wrote, our model could fail miserably. For example, if Joe Biden wins Alabama, which we say has less than a 1% chance of happening, Joe Biden did not win Alabama. Or it could land somewhere in between. For example, if Biden wins the Electoral College, but with just 51% of the popular vote, which is at the end of our forecast interval. Well, Biden actually got about 52% of the popular vote. So it was within our forecast interval. But it can't really succeed brilliantly. Even if our model correctly predicts 49 states or whatever, that's as much luck as anything else, as our estimates have margins of error. Well, the funny thing is our model did predict 49 states correctly. But I don't want to go around telling people. So I was all prepared for the model's going to predict 49 states correctly. People are all going to say our forecast was perfect. And I was going to have to explain to people that it wasn't. But of course, I don't need to explain that because everyone knows that the forecast wasn't perfect. In understanding what went wrong with the election forecast, I want to do two things. First, I want to tell you what went right with the forecast. And then second, I want to tell you the information that was used in constructing the forecast. Then we can think looking forward about how we can do better. So what went right about the forecast? Well, we thought Biden was going to get 54.5% of the vote, and he got about 52.5% of the vote. So our forecast was off by 2 percentage points at the national level, and it was off by more than 2% in some states and less than 2% in some other states. What was of course, you know it's not going to be perfect. So what was right about the forecast was that it had a margin of error that accounted for things possibly going wrong, as indeed they did. Now, given that, we have to say what information went into the forecast. So to forecast the presidential election, we use several sources of information. The first is fundamentals. So predicting the national election outcome based on national political and economic conditions. So that would be the state of the economy, for example, as measured using per capita economic growth during the year preceding the election. Political fundamentals, such as whether the incumbent is running for re-election, and the popularity, the approval of the president in the months before the campaign. Now, incumbency is interesting here from a statistical perspective, because incumbency comes into the model not so much as a main effect, but as an interaction. And what I mean by that is when an history seems to show, and logic, theory and logic also would imply, that the impact in forecasting the election of economic and political fundamentals is larger when an incumbent is running for re-election than when he's not. So because the incumbent president was running for re-election, that suggested that the poor economy and his low approval would give him gives a low forecast for how well the incumbent was going to do, how well Trump would do in the election. Now, the only tricky part about this is that over the years, in recent years, we think fundamentals are less important because of political polarization. So, for example, in 1984, Ronald Reagan got 60% of the vote. Well, there was an economic boom at the time, but I don't think that if you were to have a similar economic boom now, you would get a candidate getting 60% of the vote, because the two parties are just too isolated, and there are just too many Democrats who are not going to vote for a Republican and too many Republicans who are not going to vote for the Democrat. So that's included in our model, that the fundamentals matter, but not as much as before. The second part of our model is the relative positions of the states. So if you can predict the national election and you know the relative positions of the states, then you should be able to predict the election for each state. And of course, that was very important. Everyone anticipated for Biden to win the Electoral College, he was going to have to win something like 52% of the vote, which is what happened. And we know that because from one election to the next, the relative positions of the states don't shift by very much. The third piece of information is national polls. So the fundamentals-based forecast has a big margin of error to it. The polls, we can use Bayesian inference to partially pool between the polls and the fundamentals. The next piece of information is a time series model, because a poll is a snapshot, not a forecast. So if we have if it's September 1st and we're making a forecast of the election, we have polls up to September. Our fundamentals model is predicting what's going to happen on November 3rd. I think that's what election day was, or November 4th, whatever it was. The fundamentals model is predicting what's happening on election day in November. To link the data to the election, we have to have a time series model of how public opinion can vary from day to day. The final piece of information that's in our model are the state polls. State polls are kind of overrated in importance in some way. We pretty much already know the relative positions of the states before the election is even going to occur. State polls don't provide us much information beyond the national polls, but they provide a little bit of information. In connecting, in a statistical model, we need to connect the data to the underlying thing we care about. The polls are measures of public opinion, but we know from historical data that the polls can be off. We found that the empirical error in a poll is about twice the stated margin of error. And not only can polls be off, but polls can be off in a correlated way. So having 100 polls doesn't mean that your standard error goes down by the square root of 100. I could have 1,000,000 polls, but all the polls could be off. And indeed, in this election, the polls in aggregate were off by about 2 or 3 percentage points, more in some states and less in others. Now, there's some interesting statistical research here, which is trying to understand how our model is going to work. And so we haven't published any of this yet, but we've been playing around with ideas like refitting the model, where you take some data out, or where you take some data and shift the data, and to see what the inferences look like. And people sometimes will talk about the impact of one particular poll on the forecast, but that's not really important. One particular poll doesn't tell you that much, but what about all the polls together? So the reason why we landed somewhere in between, we did not succeed brilliantly because there was systematic error in the polls. And we allowed for the possibility of systematic error in the polls, but we didn't have a statement about which direction the error would be in. In previous elections, sometimes the polls have favored the Democrats, sometimes the polls have favored the Republicans. We followed a kind of economic argument, which is that the survey organizations are motivated to be accurate in their inferences. And so as a result, we wouldn't expect there to be a bias in one direction or another. Or to put it another way, we expect there to be some bias, but we wouldn't know ahead of time what that would be. We think the reason why the polls were off was because of differential non-response, that Republicans were less likely Republican voters were less likely to respond to the polls than Democratic voters, even after adjusting for demographics. Some polls also adjust for party identification and how you voted in the previous election, but even then it seemed that there was differential non-response, possibly having to do with people who vote differently than their party identification or with independents. The other difference is voter turnout, and so it seems I think we still don't know the full story, but there's it seems that Republicans were doing more voter registration and in-person campaigning, and Democrats weren't, and some of that did show up in new voter registration numbers. Also, it's possible that the well-publicized early voting by the Democrats motivated more Republicans to then show up on election day to counter that. So, of course, an election is a dynamic system. And finally, the reason why we landed somewhere in between and did not fail miserably is because we were historically motivated and allowed for the possibility that the polls could be off. Now, when preparing this forecast, it has all the moving parts. We thought a lot about how this information is communicated, and we did a lot of simulations, as I said, of our own forecast, and we examined others as well. And we learned a lot. So it's interesting. In the forecasting world, it's generally accepted that people have a motivation to be overconfident. And so I always give the example of the auto mechanic. So if you take your car to the auto mechanic, it's not running right, he'll say, oh yeah, there's a problem with XYZ, and then you leave the car there, and then you come back the next day and he says, well, it wasn't XYZ, it was this other thing, but don't worry, I fixed it. And you pay him and everybody's happy. If you go to the auto mechanic and you say, what's wrong? And he says, I have no idea, you might just go to a different auto mechanic. And then when you talk about doctors, sometimes people say you're actually paying for the certainty more than anything else. So there are a lot of motivations. As a statistician, I spend a lot of time fighting this motivation to be overconfident. It's just very easy people want you to be. So being overconfident is like saying, I love you. Like people, you always, in any relationship, you're kind of in pressure to say, I love you, because you get immediate positive feedback. But yet, you shouldn't just go around telling people you love them all the time, right? And so similarly, it's so tempting when giving a forecast to go into pundit mode and say, I am sure. And if you're a statistician, well, I know I'm not supposed to say I'm sure, so going into pundit mode would be putting out numbers and saying, well, the probability is 58% or whatever it is. And we have to be careful about that. So as a statistician, I'm always criticizing scientists for writing papers where they say, we've discovered this, we're sure of this. And like, then when things don't replicate, then people are like, oh yeah, well, not everything replicates. And then like, why were you so sure before? Oh, we didn't really mean it. We're just saying that. So we don't want to be like that, right? You don't want to be that guy who's always overconfident. In election forecasting, though, forecasters got burned by some previous elections. People are surprised by things. So sometimes there's a motivation to be underconfident. Because so imagine what you're a forecaster and what you do is produce 50% intervals for a living, and people stare at your 50% intervals. Well, every time the truth is inside the interval, you succeeded, and what's outside the interval, you failed. So that creates a kind of economic motivation to supply 50% intervals that are too wide, so that they're more likely to contain the true value. If your 50% intervals have 70% coverage, then it looks like you succeeded 70% of the time. Well, of course, someone could check, but with elections, there aren't that many ways to check. It was funny because the 538 website had a chart where they showed the calibration of their forecasts their election forecasts based on hundreds of thousands of forecasts. Now, you might wonder where they got hundreds of thousands of elections. They've only actually been running for something like 6 elections. So they got hundreds of thousands by looking at all 50 states and getting the forecast for every day for every state. But they're not independent events, right? So you don't really have that. So we can't really evaluate the calibration. That's why I said your forecast can fail miserably, but it can't succeed brilliantly in the same way. That is, if my interval is this, and the actual election outcome is way out here, then I've failed miserably, right? So if our 95% interval for Biden's vote share was something like 51.5% to 57.5%, center to 54, something like that, and the truth was like 52.5% at the national level. So let's that's the way it goes, right? If that had been our interval and Biden had only got 49% of the national vote, or if he had got 60% of the national vote, then you could say we were way off. So there's this motivation to always make your interval a little bit wider just in case. But that's okay, you should just be aware of that. The complicated thing where the math comes in is that I should say we did everything in R and Stan. So that's why this is the R conference. We used R and we used Stan. It's the way the math comes in here, it's tricky, is that we don't just forecast the national popular vote, we forecast the state votes. Now, I keep saying if you forecast the national popular vote and then you assume that the relative positions of the states are known, you're going to get like almost all the way there. But people want the separate state forecast, so that's fine. When you combine, you can think of having 50 state forecasts, which you aggregate to get a national popular vote forecast and to get an electoral vote forecast. And we noticed something, which was that we knew we wanted a certain width to the national forecast. Like we had a sense historically of how far things could be off. Like we would not want our forecast to have been 54.5% of the vote plus or minus 1%. That would have been too narrow. And so we also we have inferences for the states from state polls. And if you assume that if you have 50 different states and you assume the state errors are independent of each other or close to independent of each other, then when you have reasonable state uncertainties, then your national uncertainty is way too narrow. So if you don't want an unreasonably low national uncertainty, you have to either make your state uncertainties very wide, or you have to put high correlations between the state uncertainties. And a high correlation means that if Biden did better than expected in one state, you expect he did better than expected in other states. And we found from that, it was interesting. So we knew this because we had worked really hard and we did it wrong at first. We had to change our model because our intervals were too narrow, and we realized that our correlations were too low and they didn't truly represent our uncertainty. But then we did notice the forecasts on the 538 website and the state forecasts were way too wide. So they had Joe Biden having a 6% chance of winning South Dakota, which was really never going to happen. And they had Trump having a chance to win New Jersey and California and all sorts of other things. And we realized what had happened was because their correlations between states were too low, they had to make the state errors really large in order to get a reasonable national error. And like the way I'm describing it, I hope it all makes sense and it all comes out right. But when you're actually building it with all these moving parts, it's not so clear. And I think what happened to them was they kept adding new features to their model and they ended up with this wide uncertainty, which didn't make sense. But then so what if if Biden has a 6% chance of winning South Dakota? He's not going to win it anyway. So what I want to say to you, I want to end a message to you because I think that you and your work, I should have said this at the beginning. So pretend I said this at the beginning. All of you are forecasters. All statisticians are forecasters. Even if you don't think that's your job, it is. Even if you're only doing exploratory data analysis, people are doing it because they're interested in what's going to happen next. Even if you think you're doing causal inference is a forecast for what could happen given what treatments are occurring, right? Whatever you're doing forecasts. And it's very hard to get all the dimensions of a forecast right. If I'm only forecasting the national election, that's kind of easy. I mean, it's not easy to get it precise. I have a big standard error, but I just say that's all I can do. But when you're doing a complicated forecast, like if it was a business and you were forecasting sales in many different divisions, or if you're a government agency, maybe you're forecasting recidivism among many different groups of people, maybe you're forecasting uptake to a new government program, you're forecasting something that's multidimensional. It's very hard to get that all working at once. I think Bayesian inference is the way to do it, but it still depends on the model. And whatever you try first isn't going to work. Whatever you try second isn't going to work. Then you're going to find that the forecast is wrong in the dimension that you care about, and you have to fix other parts of the forecast. And then you do that, and it makes other things not work. This is kind of what happened to us, what happened with 538. What I want to say to you to conclude is I want you to embrace that process. I want you to take your forecast and look at all the weird things, look at the weird corners of the map and all the places where you made a map and there's a discontinuity across states and it shouldn't be, and that's because one of your state level predictors is wrong. Whatever it is, when you see a problem, you can't necessarily fix it because you're under a time constraint. So when you write your report, you should say, this is my forecast and I stand by it, but no, I don't really think Biden has a 6% chance of winning South Dakota. We just haven't fixed that part yet. Be open, embrace it, because that's how you're going to learn, right? If you accept, this is you are a sinner, when you accept that you are a sinner, then you can do better. If you come in thinking your forecast is going to be perfect, you're going to mess up. But once you realize it's going to be wrong and you can admit it, then you can learn from the places that it was wrong. And that's what we have to do. And part of that is going beyond it worked or it didn't work. Right? How do we learn things things had a problem? Is because first we're willing to recognize there are places where our forecasts messed up, but we're not just saying, oh yeah, it all sucks, right? There were some things that worked and some didn't. And I would like you to think of this talk as a model for how you can proceed in the problems that you work on. And that is all.
Thank you. Another classic no slides talk from Andrew Gelman. I hope everyone enjoyed that as much as they have enjoyed him in previous years. It was a good barn burner. Didn't get much controversy out of that one. We have to get some in a post-conference interview. So that brings us up to our first